Alright guys, what's up? We are looking at lesson 6.7, which has to deal with angle measures and their segment lengths. So basically what's going to happen in this lesson is you're going to have a circle, and you're either going to have two lines that are going to intersect inside a circle, or they're going to intersect outside the circle, and there's going to be various things that you can do to find the angle measure and the segment length. So the first thing we're going to look at is right here, looking at the number 1. It says the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measure of the intercepted arcs. So if you look at the circle over here on the right, does everybody see where number 1 is? In order for us to find angle 1, literally all I have to do is the measure of angle 1 is going to be equal to 1/2 of the arc x plus y. So literally all I have to do is take arc x, which is this guy right here, and arc y, which is this guy right here, add those two together and multiply it by 1/2 or divide it by 2, and that's going to give me the measurement of angle 1. So that's what happens whenever two lines intersect inside the circle. So now looking at number 2 down here, whenever two lines go through a circle but intersect outside the circle, so does everybody see where my dot is? Everybody see where my dot is? And everybody see where my dot is? The circles intersect outside of the circle. So what you'll do is it says, if they intersect outside a circle, it is half the difference of the measures of the intercepted arcs. So what you're going to do, since they intersect outside the circle, you're going to take x, and you're going to take y, and it said here the difference. So that means you're actually going to subtract x and y and then divide it by 2. So if we look here at the one that I just marked, if you look, arc x is bigger than y. So in order for me to find the measurement of angle 1 inside this situation, I'm going to take 1/2 of x minus y. So I'll always have to take the larger arc, which is x here. So if you look, which is x, and then take the smaller one and subtract it, and then take 1/2 of it. So it's the same thing here. So we have the larger arc x, the smaller arc y. I'm going to subtract those two and then divide it by 2, and it's going to give me the measurement of angle 1. Same thing right here. Larger arc minus the smaller one is going to, and then divide it by 2, and it's going to end up giving me that mark right there. Okay? So that's how you end up dealing with angle measurements. So now if we look down here at Theorem 12.12, we're going to be looking at how to find segment lengths. So at any point, it says here, for a given point and the circle, the product of the lengths of the two segments from point to the circle is constant along all the way through the point and that circle. So just like we had above where we had two lines cross each other, whenever that happens, the points where they cross each other inside this situation, inside the circle, they're going to be proportional to each other. So literally all I have to do is take line A. Here, I'm actually going to erase that real quick so we can see it. I'm going to take line A, multiply it by B. So A times B is going to be equal to C times D, which is that guy right there. Okay? So all I have to do is take A, multiply it times B, and that's going to be equal to C times D. Now looking down here, this is where it gets a little tricky, but it's actually pretty simple whenever you look at it. So if you have two lines that go through a circle, but they cross outside of the circle, there's going to be a situation that's going to happen to where I can end up finding the measure of any one of these angles. But what you have to know is in order for me to find one of the lines, this is going to be the formula you're going to look at. So in order, right here, there's going to be a relationship up top. So the top line, I'm actually going to take W and X. I'm going to add those together, which is inside the parentheses. Then I'm going to multiply W and X times W right here. And then that is going to be equal to Z plus Y, which is right here and right here, multiplied by Y. So the way I like to look at it whenever I'm doing this, ladies and gentlemen, is you're going to take the whole line, put it in the parentheses, and then multiply it by what is outside the circle. So x and w inside, and then w is outside, so I'm going to stick it on the outside of the parentheses. And that's how we can end up finding our measurements by doing this. And I'll show you down in the example down below. Okay? And then lastly, if you look here, I have a line going through the circle right here, and then I have one line that is tangent, meaning touching the circle at exactly one point outside of my circle. So whenever this happens, there's going to be a special relationship. So on the bottom line, you can see it goes through my circle, so I'm going to do the same thing I did on the last one. I'm going to take z and y, I'm going to add those together, and then y is on the outside, so I'm going to put it on the outside of my parentheses. And then now with the tangent line, all I'm going to do is take t, and I'm going to square it, and those are going to be equal to each other. So I'm going to use this to my advantage here in a little bit to show you an example. And then lastly, looking down here on the bottom, I'm going to show you guys the definition of a secant line. So we learned about something called a tangent line. So a secant line is a line that intersects a circle at exactly 2 points, but it goes through the circle all the way through. So ladies and gentlemen, this is going to be known as a secant line. Alright, ladies and gentlemen, let's go ahead and look at our first example here. So it says here, a tram travels from point A to point B. So we have point A to point B. So some kind of railroad system or tram is going to travel from A to B along the arc of a circle with a radius of 125 feet. We need to find the shortest distance from point A to point B. So if you look here, ladies and gentlemen, this is basically two lines that are crossing between each other. So what I'm going to do here is I'm going to show you the relationship between these just by labeling them. So I'm going to call this A, I'm going to call this B, I'm going to call this C, and I'm going to call this D. So what this is going to do now is we know from our lesson or from a while ago that if I take A, multiply it times B, it's going to be equal to C times D. Okay? So with this being said, now we can use this information to try and find our length going across from A to B. So let's go ahead and look at this. So both A and B in this situation are represented as X. So that means I'm going to be doing X times X. And then C is represented as 50. And then to find D, we know that the distance of the radius is going to be 125 feet. So if I look here from the center of my circle all the way down here to the bottom is going to be 125 feet. And then I know from the center all the way up is going to be 125. So if I take 50 from that, it's going to equal 75. So if I add that together, D is going to be equal to 200. So I'm going to multiply that by 200. So now literally all I have to do is some algebra and figure out what the value of x is going to be. So if I take x and multiply it together, that's going to give me x squared. Then 50 times 200 is going to give me 10,000. And now we know to get rid of the square root squared, all I have to do is take the square root of both sides. So when I take the square root of 10,000, that is going to end up giving me 100. So now it's asking from point A to point B. So look here, x I know is 100, x I know is 100. So that tells me from point A to point B is going to equal 200 because I would add those two together. So ladies and gentlemen, we just now used the A times B equals C times D here to find the answer to this problem here. Alright, so next up on my problems here, I need to find the value of W. Well, first let's go ahead and look at our situation. We have, it looks like two lines that are meeting outside the circle, and I know to find 70 degrees right here, all I have to do is add the two arcs together and actually find the difference between those two and find 1/2 of it. So let's go ahead and look at this. So I know to find this angle right here, I know to find the measurement of angle 1 is going to equal to 1/2 of x minus y. Okay? So remember earlier x was the bigger arc and y was the smaller one. So let's go and plug in what we know. We already know the measurement of angle 1 from earlier, which is 70 degrees here in this situation. And then I'm going to take 1/2 The bigger arc here, going all the way around, is represented as W. And then I'm going to subtract y, which is going to be 110. So now literally all I have to do is solve to try and figure out what's going to go on here. So then I know if I look here, to get rid of 1/2, all I do is multiply by 2 on both sides. So 2 times 7 is going to give me 140. And then the times 2 is just going to get rid of the 1/2. So then I'm going to get W minus 110. And then all I have to do is add 110 on both sides. And then W is going to end up being, 250. So your final answer is going to be 250 degrees. Because if you look, 250 and 110 is actually going to equal 360 degrees. So we ended up using our formula here to find the measurement of W here. So now lastly, we're going to look down here at the bottom, and we need to find the value of x to the nearest tenth. So right here we can see I have 2 lines that are meeting outside of the circle, and I'm needing to find a measurement, but there's no tangent line here. So I know earlier that I think I did this, which was W plus x multiplied by W is going to be equal to y plus z multiplied by z. And so I'm going to label these just to go ahead and show you here what's going on. So if I look here, I'm actually going to take a red pen here. 20 is going to be my x. 14 is going to be my w. This guy down here is going to end up being my y. And then 16 is going to end up being my z. So literally, now that I know my formula here, all I have to do is plug everything in. So I'm going to take the whole line above, so 20 and 14. So I'm actually going to take 14 plus 20. So W is 14, X is 20. W is 14 here. Y, I'm just going to go ahead and leave it as Y. Z is 16. And then Z is 16 here. So I just plugged all my numbers in. So right here, let's go ahead and look at this. So 14 plus 20 is going to give me 34. 14. I'm going to leave this as Y plus 16. So 16 times Y is going to give me 16Y. And then 16 times 16 is going to end up giving me 256. And then 34 times 14 is going to give me 476. So let's go and erase this right here. And I'm going to get 476. Now literally all I have to do is solve for y. So I'm going to subtract 25, which gives me 451. And then I'm going to divide by 16, which to my nearest tenth up here, y is going to be equal to 28.19. So your final answer should be 28.19.